When you think of proteins, you probably picture meat. But biochemically speaking, proteins are a lot more than what's for dinner. Enzymes, antibodies, even our muscles are all protein-based. It's an elegant system, says chemist Kent Kirschenbaum.
Every time we think that we can beat Mother Nature, we are humbled over and over again.
But they keep trying.
We can either engineer natural proteins, or we can engineer synthetic molecules to mimic the shapes, structures, and functions of natural proteins.
With support from the National Science Foundation, Kirschenbaum and a team at New York University are developing new methods for making synthetic proteins in the lab. They see a future not far off when they will be able to handcraft proteins that have never existed before in nature and put them to work at the industrial scale.
We've really developed the building block approach to crafting these molecules in an extremely reliable way. We're confident that if we can design a molecule, we're going to be able to build it.
Imagine synthetic antibiotics that could fight infections like MRSA, custom pharmaceuticals to treat advanced prostate cancer, and new enzymes that will turn cellulose into fuel. Inside our cells, biochemical factories build proteins brick by brick, so to speak, the bricks being amino acids. In Kirschenbaum's lab, they've developed methods to do much the same thing on these tiny beads that they load into a syringe.
The beads provide a very nice surface area, and they're also porous so that the chemical reactions can take place on their surface and in the interior of these beads.
The big challenge is to engineer their synthetic protein so it folds itself into an exact duplicate of the natural one. Because if the shape of the molecule is even a little off, it won't work as designed. So far, they've had good success synthesizing relatively small ones.
This is a huge, huge deal. We are really at this threshold. What we need to do is take this to the next step so that we're not just mimicking short individual units, but really mimicking the complex three-dimensional arrangements of some of these massive protein structures. Then a whole world of applications will open up for us.
That could lead to advanced materials, cleaner and more efficient fuels, better drugs, and more effective healthcare treatments. Faith Lapidus, VOA News.